Hello everyone, and thank you again for joining us today for our fourth HashiCorp snapshot session titled Nomad Scheduling 101, Why Let Container Runtimes Have All the Fun, which today will be presented by Anthony Burke, Senior Solutions Engineer. So today Burke is going to talk about scheduling with Nomad, specifically how Nomad provides a streamlined approach to scheduling, both modern and traditional application runtimes. I also want to note that this session is being recorded and a recording will be made available after post-processing. Usually takes a day or two, but I'll send an email out to everyone who registered so you'll have a link to watch it in your own time. So today's demo will last about 15 minutes, and to keep it to time, we won't have time for Q&A during the session, but if you do have questions, post them there in the Q&A tab at the bottom of your screen there, and we'll get to them at the end of the presentation. So with that, let's go ahead and get started. Over to you, Berkey.
Hello, everyone. I'm Berkey. Thanks for the introduction there, Pete. I'm Berkey. I'm a Senior Systems Engineer, Solutions Engineer for HashiCorp. I've come off paternity leave to deliver this session, so I've got a 2-week-old daughter. So I apologise if there is any screaming in the background or anything like that. But I'm looking forward today to talk to you about Nomad. My background, I've spent a lot of time working with application runtimes over the last 4 or 5 years with different container schedulers, application schedulers, and I wanted to share some of the pretty cool stuff about Nomad and why it differentiates itself compared to others. So today's going to have a little bit of an introduction, a bit of a recap and sort of level set, and then we'll move into a demonstration showing a application architecture comprised of various runtimes in a live demonstration. So let's get started. As Pete mentioned, if there's any questions, use the Q&A feature of Zoom, and they'll be either answered live by some of my team members in the chat, or they'll be followed up in the transcript at the end. All right, let's get rolling. So let's talk about this slow migration from applications that are running traditional architectures and moving this idea of taking an application and putting it onto a cloud or staying on premises. Now, for a lot of people in the, and I air quote this, cloud adoption story, is that there's this I have to lift and shift. So I have to lift up a workload and move to cloud. Or to take a full advantage of cloud, I need to re-architect my application. I might have a traditional Java application or a payroll application that's built from traditional runtimes like Java or .NET that needs, there's this illusion that needs to be re-architected. And so there's this dilemma, a paradigm of I have to re-architect something before getting the advantages of consuming cloud or consuming a runtime, such as a scheduler. So moving to that presents a dilemma for many businesses. And the idea here that, well, I need to make a choice. Do I re-architect and move to cloud, or do I just lift thing and stay on premises? So when you look at the whole notion of re-architecting, when you talk to people, they go, hey, I just put it in a Docker container and it works, right? I can containerize my application and that's it. But when you think about your existing runtime, if it's a Java running on a virtual machine, you've already nailed down the networking. You've sorted out the storage. You know how the security works. You know how all the lifecycle operating system works. When you shift to a container runtime, you need to actually think about all of that before you productionize the runtime. So you can think about Docker, let alone the orchestration, the running, the health checks, the lifecycle, the networking, security. It goes on and on. And the big thing here that people need to think about is that it becomes a complex thing running parallel architectures. You have a traditional architecture of what we call older or legacy applications, and then you've got another architecture designed around containerized applications. And this is where something like Nomad seeks to bridge that gap and provide a nice middle ground. Nomad is one of the HashiCorp products that works to provide a consistent application runtime on premises, on cloud, and across multiple clouds. It focuses on that Linux ethos of doing something right and focusing on a small, narrow set of use cases and executing really well. It takes runtimes that are both containerized, like many other schedulers out in the market, but also allows us to schedule non-containerized applications such as Java processes, execute local commands and runtimes against underlying operating system, and provide controls and security around that, whilst bringing all the benefits the container scheduler would have to these applications. So it means that I can, with very minimal overhead, provide myself a Nomad job file, reference my traditional Java application, and schedule it like I would any other containerized application, getting the benefits of availability, ease of deployment, scale, canary testing. It goes on. So Nomad is a very, very powerful tool that is often overlooked because other orchestrators do take the oxygen out of the conversation. So the guiding principle behind the engineering development of Nomad is that we want to be able to orchestrate any application. If that's a virtual machine, if that's on Mac, if that's a Linux file, if that's a Java file, a Docker container, we don't differentiate. We treat them all the same and provide a consistent runtime for those. So the language used, the Nomad job files and specifications used provide consistency for that runtime, and you can provide those controls for them. So yes, containers are a thing we support, and whilst we're going to focus on non-containerized applications today, providing a consistent way to schedule containers across on-premises, across clouds, and across underlying operating systems, be that Windows, Mac, or Linux, Nomad allows that to do. Using a simple 35 meg binary, we can install Nomad to an underlying operating system, a virtual machine, either on-premises or off-premises, which allows us to get up and running with Nomad pretty quickly. Unlike having to architect a very elaborate solution, Nomad's simplicity allows a very quick time to value and easy to adopt. Looking at the non-containerized applications, I can take potentially a older workload or a workload that is pretty stagnant and provide infrastructure robustness, application robustness around it by looking to schedule it with Nomad. So the ability here to introduce things like canary testing or minimize development lifecycles by integrating a pipeline allows me to take this what was seen as the holy grail, or the you mustn't touch this server because it may break, and provide some rigidity and robustness around that application to ensure it can handle failure, tolerate outages, or if need be, if it's a health check that fails, be rescheduled elsewhere. All right. So on the right-hand side here, I have a bit of code. This code here describes a task driver. Now, the flexibility of Nomad is task drivers allow us to differentiate what type of workload inside our job we want to schedule. I can have one Nomad job, of which I can use multiple task drivers. Now, a task defines a set of explicit commands that we want to run and how we want to operate, but I can have in the same job file what we call a local exec, so something run on the underlying operating system in an isolated process. I can have to run something on a Docker container, and I can then run a QEMU virtual machine. And so the idea here is that Nomad will take this, interpret what you're doing based on the driver, and provide that and program the underlying operating system accordingly. So here we can provide a common language in the Nomad job file that is interpreted by Mac, Linux, or Windows Nomad clients. So you can see here an example of a bit of a spoiler for the demo coming up, but I can see here in one visual UI or via a command line or API, I can see a variety of jobs running on my environment. I can see I have a web server, I have a load balancer, and I have Minecraft running, which is fantastic. So it doesn't matter what type, I've got a mixture of containers and a mixture of local processes, and I have a mixture of Java applications, all running happily across my infrastructure. I destroy a node, my node gets unwell or fails a health check, those workloads are rescheduled elsewhere, and through service discovery and other methods available in Nomad, that workload is accessible. So a big thing, and one of the big discussion points that people get caught up in, which is a really, really strong value proposition of container runtimes and schedulers, is having a notion of a zero downtime deployment. So I can roll up from version 1 to version 2, or move from one by one incrementally upgrade my applications. When you look at traditional monolithic applications or legacy applications, it's generally bring down that virtual machine, patch it, bring it back up, and it's very manual. It can be automated with scripting, but it's a bit of a tedious process. The notion of a scheduler takes control of being able to upgrade and uplift X percentage at a time, and making sure that if I'm rolling from version 1 to version 2, is it successful? Yes, and I'll only do a subset of that application. Further, that once the application's healthy, I'll then remove that version 1 client. And you see this incremental upgrade occur through my environment, which allows us to slowly and consistently bring it into production. Alternatively, these rolling deployments or canary tests can be used for, I want to launch a new part of my website or web front end, and I can actually say, X percentage of traffic can come through to this workload, and the rest goes to the old website. So it lets you have that sort of placebo testing for many people, or A/B testing. And these having a common language via the Nomad interface to do this allows us to provide this functionality independent of what application runtime is running. So you're bringing the value of scheduling to traditional applications. Health checks are a big part of it. So you can see here that when we evaluate a application, we place an application down. Nomad will constantly check an application to see if it's healthy, if it's accessible on a certain port, is it a web page rendering, or is it doing a heartbeat check? And if that fails, and the job becomes unresponsive, Nomad's responsible to restart it. Again, we don't care about the application runtime, we just want to make sure that job restarts. And so here, you have this innate ability to provide health and resilience to application, where beforehand in a traditional runtime on its own, outside of Nomad, you have to build this yourself. So it's something that takes away a lot of the administration elements of supporting traditional runtimes by placing that runtime under a scheduler. And resource utilization. Now, when we think about what we do when we deploy, sometimes you deploy a virtual machine, and having been an ex-vSphere administrator for a long time, and having worked a long time at VMware, you saw a lot of people would deploy a individual virtual machine, and of which one application will run, just the Java resource, right? And that wouldn't be an ideal thing. This would be, okay, I've got a very big bloated VM with just one process on it. On the other hand, a scheduler will say, okay, I'm going to strategically place, based on the resources, the allocation, and the calculation across all of the agents, where I'm going to place it based on a given time. So it allows me to put the best allocation of resources. The same way if you throw all of your Lego into a box, you're going to fit some in. But if you neatly pack it all, you're going to fit a lot more in, right? It's the same thing here. I can neatly pack the blue and green applications, as depicted on the bottom here, together nice and neatly, and maximize the footprint. So this means when I have things like auto scale and other components in scaling up my environment, I can ensure that I'm using the right amount of resources at a given time without having to over provision. So it's a very smart way that the scheduler takes control of the nightmare of resource allocation and administration. Just super. All right, so now I've waffled on for a little bit, for 10 minutes. This is going to be a short presentation, so I'm going to get into the fun part, which is the demonstration. So today's demonstration, we're going to run, quietly titled Java and Docker and local exec, oh my, almost like it's lions and tigers and bears, oh my. But the notion here is from a simple set of job files, which I'll go through, I'll be able to deploy a Java application, which will be in Minecraft, a Docker application, which will be a web server, and then I'll be able to deploy a load balancer, but the same way as I would do apt-get install on a Linux box using a local exec. So here I'll be submitting the job. You'll see it spawn. I'll access and interact with it, and we'll go from there. Excuse me. Okay, the joys of your kids going back to school after all this, you get sick. All right, so let's get this going. I'm going to slip across here, and I can look at my Nomad interface. Now, I said before, Nomad has a UI, a CLI, and an API. Today I'm going to demonstrate using the UI and the CLI, which I'll show you how to submit a job, view a job, and actually view it running. So you can see here in my production region, I've got multiple regions, but I have my production region and my default namespace. I've got no jobs running, absolutely nothing running. I have a Nomad server. A server is the one that makes election decisions. Leadership allocates jobs to different nodes. The clients themselves are just the workers who will sit there and take jobs that get deployed from the server itself. The reference architecture goes into detail about how this all deploys, but for my lab running here on my computer here, I have one server, 3 workers. So there's no jobs currently running. So what I'm going to do is I'm going to look at a couple of my jobs. So first of all, I'm going to deploy a load balancer because I want to ensure that when traffic gets deployed, it reaches my servers, they're pushed to the right instances correctly. So let's have a look at the Fabio job file. Now, going through this, I can see here it's a very common language that we use, a very consistent language, and the hierarchy is broken down in our documentation. But essentially, we have a job, a group, and a task. Right? A job is the representative of the entire file. You can have multiple groups, of which groups can have many tasks. You can see here, I'm going to deploy a job called Fabio in Data Center 1. It's a system job. I'm going to deploy, make sure that on a system job, we'll schedule something on every single node or client available. So I'm going to ensure that I'm going to have one instance of Fabio available on every single node. The task driver is going to be raw exec. So essentially run it as a local command. So it will essentially allow me to go, I want to install a load balancer on the underlying node. Right? You can allow this, you can deny it based on your permissions, but this is what we're going to do. It's going to go off and pull from GitHub the release of Fabio 1.5.4. Right, that's it. And then it's going from that, it's going to literally, as part of the artifact stanza, it will extract it and install it. Or just run it. And then the config command will be to run it. I'll assign some CPU and resources to it, nothing fancy there, and open up a number of ports. So happy days. So to run this, I'll do nomad job plan Fabio. Now plan is a dry run. Plan will go through and look at it and go, am I happy with what's information's here? Can I actually schedule this? It will evaluate the environment, look at the nodes. At this given time, can this job run? Are there enough resources? Absolutely. So I'm going to submit this job with verification. In other words, it's going to query Nomad, look at the pre-approved list of jobs we've submitted, and this spec has been submitted, and run it. So I run it. It's going to spin up and spawn Fabio on those 3 nodes. You can see here on the left side, my UI has reflected this. It's slowly scheduling them there. You can see it's gone happy. So there's 3 running. Happy days. Fabio's running. It's got a guaranteed level of resources. You can see here on each node, Fabio spun up, and you look at a bit more details. I can see it's opened the ports I've asked it to, which matches the code that I wrote. We're cooking with gas here. So just to confirm this, I'm going to make sure that we go crazy. Fabio has an administration interface, which I can view on port 998, and I can see it there. Fantastic. This is running. I'm very happy. Now, let's put some real workloads on here. Okay, so I'm going to have a look at my current cat web server, I think it's called. Microbot. Right. I can see here I've got a microbot here. A microbot is allowing me, it's going to deploy same sort of thing. Job microbot. It's going to be in data center 1. It's going to be a group. We want 3 of them. I want 3 of these, and it's going to use the Docker driver. So then from that, we're going to configure a port map, which port we want to expose, the container, the image itself. And this can be pulled from Docker Hub or your private registry, whatever needs to be done there. And I'm just going to throw a couple of little bits of tidbits of information about this environment into it. Mostly a tag, just so my load balancer finds it dynamically. But other than that, it's a pretty straightforward file, right? A good habit is to do nomad plan microbot. Right? I can see that I can be deployed and allocated. That's fantastic. And I'll run it. For those that want to live on the wild side, you can just do nomad job run, and it's going to run that for you. So I'd rather be thorough, but I can see that allocation's been made, which is fantastic. So just jump back to the jobs here. Now I have a containerized application fronted by a load balancer. Very straightforward, but very common pattern to see. But something that shows it off pretty well. So you can see that 3 workloads spun up very quickly. I can see that they're running here. And if I refresh this, I'll see that from behind a load balancer, my traffic's getting to that container. And if I refresh here, the container host name is changing. So CFD, CDA, 4F5. So you can see here that I'm being rotated or load balanced through my environment nice and neatly. That's through the console, the service discovery element, and Fabio doing that load balancing or listening for that traffic. So there's a container workload and a local exec workload. And for the piece de resistance, I'm going to have a bit of fun. Let's say it's 4 o'clock Friday. On this case here, it's almost 2 p.m. on Tuesday. I'm going to spin up a game. I want to play some Minecraft. So I'm going to cat Minecraft because I want to run a Minecraft server. Now this is a Java file. Minecraft gets packaged up nice and neatly in a Java file. So I'm going to deploy it. I'm going to assign a fair amount of CPU and resources for this. I'm going to do a couple of things here. You can see here, there's a few more requirements of this particular Java application. It's air quote an older application in the sense it needs to have an EULA approved and user license agreement, of which this needs to say true. There are many ways to skin a cat here. I could do echoing content to a file. I could pull it down from elsewhere. But in this case, I'm going to pull down a file from my personal GitHub, which has a EULA equals true. Then I'm going to pull down from the Mojang servers the actual server file, the Java file. And what we do from the artifact stanza is we pull out we extract the file, the zip file, we do a check on it, we place it into the directory we desire, and of which we're going to use the Java driver. We can also pass, traditionally when you run Java, if it's on a command line or a Linux system, you're going to run a heap of variables or pass variables to it from a configuration file. I'm configuring here maximum memory and minimum memory required. So I'm going to give it 768 meg of memory at a minimum to run, which is totally awesome because we've guaranteed it's going to have 750 minimum. So we're cooking with gas. We're happy here. And we're going to go from there. So I'm going to run this one. Let's click clear, and then Nomad job run Minecraft. You can see that I didn't plan, so I'm living on the wild side here. But what happens here? Minecraft, it's going to pull that file down. It's going to download it. So it's doing that deployment. It's going to run it. It's going to pull it down very quickly. It's going to spin it up. Now Minecraft takes a few seconds to boot up because reasons. It spawns the world. But while I buy myself 30 seconds for it to spin up correctly, you can see here it's happily running. I can view that is nicely highly allocated. I can view here that, yeah, it's using, at the moment, it's overcommitted its resources. So we guarantee a minimum of 1,000, but it's currently using 3,000 megahertz to spin up. Memory's ramping up as the world's building, but we're slowly getting there, which is great. And that's really cool. So it's booting up. You can see here it's been allocated a port. We're going to join that soon enough. And happy days. You can see here that the definition file has been interpreted for when I submit the job. I can see if I do any versions. If I submit another version of the job file where the names change or I've updated the version, it will have a version history, which allows you to roll back if desired. I can see the deployment's happily running. I can see the allocations defined, and I can see the evaluations, where it evaluated all the nodes and which one actually wants to plummet to. Now, here's the test that Minecraft should be running. It's time for game time. I'm going to open up my multiplayer server, and I'm going to boot in. And hopefully, it's going to boot up. And if it takes a while on the encrypting, I'll just run it again, because it means the world hasn't spawned. It takes about a minute or two to spawn. But that's okay, I'll just do it again. But it'll get there, and I'll be able to log in and play my game, which is fantastic, because beforehand, I would have had to spin up a server, run a Java file, but after here I can apply my job file, get up and running, and go around very quickly. Let's join this server. Come on, here we go. And allows me to play Minecraft when it's done. So Nomad allows us to schedule, commingle different application architectures, different runtimes in a very simple, straightforward fashion. It requires less overhead than other schedulers. It requires less learning, and the learning curve is not as great as other schedulers. And one of the big things about Nomad is, and many customers attest to this, it becomes a very, very straightforward thing to administer in environments and at scale. Yeah, that's all right. We'll do it this way. We're going to direct connect. I'm going to join Minecraft, join the server. And yeah, trust this to be the way it works. I was playing it before, testing it out, and now I can't get back into it. You can see here the job is running. It's just my game's not doing it. But what my important part is, I was saying, is that administrators of all walks of life, operations teams, dev teams, the infrastructure admins, can easily and simply get familiar with Nomad, know what it does, because it does its scope of works really well, and you can get on with worrying about the application itself, which is really cool. So you can see there's three things side by side. I have my Minecraft server, I have my Microbot web server, and I have my Fabio load balancer, using three different types of runtimes to deliver a service. So that's pretty cool. So in summary, Nomad looks to provide a simple way to unify and make application runtimes easy to consume, provide consistency. If I have containers, Java applications, or local exec files, or whatever it needs to be, or .NET applications, I can deliver health checks, I can deliver consistent deployments, I can deliver versioning, I can deliver canary testing. It allows you to treat them all the same. So it provides ubiquity, which is fantastic. So Nomad from HashiCorp is a super product. I hope you learned a bit about it today, and I would love to hand it back over to Pete now. So thank you.
Thanks, Berkey. Great presentation and demo. Very neat. Now, I'm just looking at whether there's any questions. I can't see any questions in the queue. So if you could just go to the last slide there, Berkey, with the details of the webpage links.
And you just saw it while Pete was talking, the Minecraft world decided to spin up and to work. So it was a matter of time. I was impatient as ever. Thanks, mate.
Glad we got there in the end. Yeah, so folks, thank you. That brings us to the end of our session today. We hope you found it useful. And I was mentioning before that don't appear to be any questions, but if you do have any questions, you can reach out to Berkey directly. Like I said, we'll be sending a link to the recording of this session after this event. It usually takes a day or two. And if you like what you heard today, I encourage you to visit our Learn pages on our website, which you can visit there on that URL there, learn.hashicorp.com. Has all the information about scheduling with Nomad there and other good stuff. And don't forget to register for our next HashiCorp snapshot. We've got VMware NSXT automation with Terraform coming up on the 24th of June. Look out for the invites. They'll be coming soon. Well, thank you again for joining, everyone, and looking forward to seeing you on the next webinar. Bye for now.